All right, so we were working this problem on Friday. We ran out of time. Right, we're solving for the angle x, right, in radians. And actually, there wasn't this problem. It was this section, but it was this problem that we were working, right? Problem C. And we had worked the problem to the point where we had rewritten the equation, right? Came up with an equivalent equation of 2 sine x squared minus sine x minus 1 is equal to 0. And so the angles that we can put for x that make the left-hand side equal to 0 here are the same angles that make the left-hand side equal to 0 up here. Did anybody take a stab at this? Brian? Okay. Brian, what did you get for
x?
For x, yeah.
Pi over 2, 7 pi over 6, and 11 pi over 6 plus the 2k pi.
Yep. That's what I got. Okay. So let's see how he came up with that. So this factors. And it factors the 2 times the sine of x plus 1 times the sine of x minus 1. And then by the zero product property, either the first factor is 0 or the second factor is equal to 0. And so when we solve for sine x, right, first equation, we subtract 1 divided by 2, and we get the sine of x is equal to minus 1/2. In the second equation, we just add 1 to both sides, we get the sine of x is equal to 1. So then the next step is to find all the angles on the unit circle that satisfy this first equation, and all the angles on the unit circle that satisfy the second equation. Okay? And so should recognize that the sine of 7 pi over 6 is equal to minus 1/2, and the sine of 11 pi over 6 is equal to minus 1/2. And then sine of x equals 1. The only place on the unit circle where the sine function is equal to 1 is at pi over 2. So those are the three angles. These are the two angles on the unit circle where the sine function is equal to minus 1/2. And this is the one angle on the unit circle where the sine function is equal to plus 1. So that gives us the three angles on the unit circle that make the left-hand side of our original equation equal to 0. And now we want to include the coterminal angles that make the left-hand side of our original equation equal to 0. Okay. So our solutions to this problem. First, I'm going to list the angles on the unit circle from smallest to largest. That's just a Robert thing. And now we add 2k pi to each of these. To include all the coterminal angles. So that's all the angles, but k is an integer. I forgot to write that. Those are all the angles that make the left-hand side of our original equation equal to 0. Yes, ma'am.
we don't have to go back and do anything with cos, do we?
With what?
With the cosine?
No.
Okay.
No, we had, in order to solve this equation, we had to replace cosine squared with 1 minus sine squared. So that we had an equation in sine x only. Okay. All right. Any other questions? Okay. All right, so if you turn over your page, we're going to introduce the other trigonometric functions. There are actually 6 trigonometric functions altogether. We've just been focusing on sine and cosine. Okay, so we're just going to introduce the other 4 trigonometric functions. Okay. The secant function which is SEC for short, right? The secant of x is the reciprocal of the cosine function, okay? So this is pronounced secant of x, right? You know, this is pronounced cosine of x. The cosecant function is the reciprocal of the sine function. So this is pronounced cosecant of x, okay? And then the third and fourth one are the tangent function and the cotangent function. Okay. And the tangent function is the ratio of the sine function to the cosine function. So this is pronounced tangent of x. Okay. And then the last one, the cotangent function, is the reciprocal of the tangent function. And so it's, instead of sine over cosine, it's cosine over sine. And cosine over sine is the reciprocal of the tangent function. Okay. So this is pronounced cotangent of x. Okay. So sine and cosine are the 2 main trigonometric functions. Okay. And we have 4 more. Okay. So did we lose? Oh, Angus just stepped out. I thought we lost him. Okay. All right. So if you had trigonometry in high school, you probably heard those names of those functions before. All right. So in example 1, okay, we have to evaluate tangent function, cotangent function, secant function, cosecant function at different angles. So in A, Now try to write them on the board the way they're written on your paper. You almost you gotta do your work vertically. We got the tangent of pi over 3. Well, by definition, tangent of pi over 3 is equal to the sine of pi over 3 over the cosine of pi over 3. Well, the sine of pi over 3 from the unit circle is square root of 3 over 2. And cosine pi over 3 is equal to 1/2. And now you're doing division with fractions, right? Keep, switch, flip, right? And when you do keep, switch, flip, you get the tangent of pi over 3 is equal to square root of 3. Okay. Any questions on that? Cotangent of 5 pi over 6. By definition, that's equal to cosine of 5 pi over 6 over the sine of 5 pi over 6. Cosine of 5 pi over 6 from the unit circle is equal to minus the square root of 3 over 2. And the sine of 5 pi over 6 is equal to 1/2. Again, you're doing division of fractions. Keep, switch, flip. And you get minus the square root of 3. In C, we have the secant of 3 pi over 4. And by definition, that's the reciprocal of the cosine function. So that's equal to 1 over the cosine of 3 pi over 4. And from the unit circle, the cosine of 3 pi over 4 is minus square root of 2 over 2. And so 1 divided by a fraction is just a reciprocal of the fraction. So this is equal to minus 2 over the square root of 2. And when we rationalize the denominator, we just end up with minus square root of 2. Any questions? And then in D, we have the cosecant of 4 pi over 3. Now you got a little space to the right on your paper. And by definition, right, cosecant is the reciprocal of sine. And sine 4 pi over 3 from the unit circle is minus square root of 3 over 2. So 1 divided by this fraction is just the reciprocal of the fraction. And we have minus 2 over the square root of 3. Now you don't have to rationalize that unless you want to. All right. Any questions on that? So let's look at example 2. We're given the sine of x is equal to 2/5 with x between pi over 2 and pi radians, right? So that's in quadrant 2. Sine is positive in quadrant 2, so this makes sense, right? Sine of x is equal to 2/5. And from this, you're going to determine the values of the other trigonometric functions. So sine x, sine of the angle x is equal to 2/5, where the angle x is greater than pi over 2 radians, but less than pi radians, right? And so angles that are between pi over 2 and pi radians are in quadrant 2. And just to remind yourself, pi over 2 radians is the same as 90 degrees, and pi radians is the same as 180 degrees. Well, of the other 5 trig functions, the easiest one to find is cosecant x, because it's the reciprocal of sine x. So cosecant x is equal to the reciprocal of sine x which is the reciprocal of 2/5, which is equal to 5/2. Okay? So cosecant x is equal to 5/2. Now to find tangent, cotangent, secant, right? We need to know cosine. Well, if the angle x is in quadrant 2, is cosine positive or negative in quadrant 2? Negative. So we can calculate the value of cosine using the Pythagorean identity. Cosine squared, cosine x squared plus sine x squared is equal to 1. So sine of x is 2/5. I put 2/5 in for sine of x. And then I gotta do the arithmetic. Right? 2/5 squared is 4/25. And 1 can be written as 25 over 25. And now when I subtract 4/25 from both sides, I get cosine x squared is equal to 21/25. And then when I take the square root of both sides, I get the cosine of x is equal to the negative square root, because cosine is negative in quadrant 2. So cosine of x is equal to negative with the square root of 21/25. And when you take square root of numerator and denominator, you get the negative square root of 21 over 5. Well, now that we know what cosine of x is equal to, we can calculate secant of x, right? Secant of x is the reciprocal of cosine x. So secant of x is equal to 1 over minus the square root of 21 over 5, which is equal to minus 5 over the square root of 21. So now we know 4, right, values of the trig function, right? The value for 4 of the trig functions. And then tangent x and cotangent x, a little more labor intensive, right? Tangent x is sine of x over cosine of x. Sine of x is 2/5. Cosine of x is minus square root of 21 over 5. And when you keep the first bracket, keep switch flip, and multiply, right, the 5's cancel, and you're left with minus 2 over the square root of 21. And then cotangent x is just a reciprocal of tangent x, right? So cotangent x is a reciprocal of this fraction. Cotangent x is the reciprocal of tangent x, which is equal to 1 over minus 2 over the square root of 21. And so when we take the reciprocal of minus 2 over square root of 21, we get minus square root of 21 over 2. And now we found the value for all 6 trigonometric functions. Yes, ma'am.
For cotangent, if it's the reciprocal, wouldn't it be negative? Oh, never mind.
Reciprocal, you just flip
I
it
see what
over,
you
right?
No, I was
Yep.
confused.
Yep. So I actually wrote out the definition of reciprocal, right? But technically speaking, you could recognize cotangent's reciprocal of this fraction. You just flip it over and be done.
Okay. Thank you.
You're welcome. Okay. All right. Any questions on that? Okay. All right, we're going to skip the problem on the back. If you want to work it at your leisure and send me your answer, see if you got the right answer, I'll be happy to give you the right answer. Okay? Tell you whether you got the right answer or not. Okay. So we got one last little thing. Takes about 5 minutes, and then we'll have all the odds and ends. Okay? Taken care of. Yes. Did you get your exam back? After stop. Yeah. So I'll be posting practice problems on Oaks for the material that we've covered since exam 4. Okay. So we're gonna talk about what's called the law of sines, just briefly. And then we'll be done with the semester, with lectures, okay? Then the party can begin, okay? Alright. So an oblique triangle has no right angle. Right? You guys are probably familiar with what a right triangle is, right? Right triangle has a 90-degree angle in it. An oblique triangle has no 90-degree angle. Okay? So here's an example of an oblique triangle. And angle A here is clearly greater than 90 degrees. Okay? This is also an oblique triangle. There's no 90-degree angle in it. Okay? And so the three angles inside the triangle are labeled big A, big B, and big C. And then the corresponding sides opposite each angle are labeled little a, little b, and little c. Okay? And the law of sines tells us, right, for any oblique triangle, the sine of angle A divided by the side opposite, little a, is equal to the sine of angle B divided by the length of the side opposite angle B. Okay? And then that's true for angle A and angle C, right? The sine of angle A divided by the length of the side opposite angle A is equal to sine of angle C divided by the length of the side opposite it. Okay? And so we also have this relationship between angle B and angle C. Okay? So these three equations are true for any oblique triangle. Okay? And then you always have the constraint that the sum of the three angles has to equal 180 degrees. So in the exercise down below, okay, you're instructed to relate angle B to angle C and sides B and C using the law of sines. If angle C is equal to 85 degrees, side B is length 5 and side C is length 6. So maybe I can draw a halfway decent picture. So angle B is 85 degrees. So here's angle B. It's equal to 85 degrees.
Here's a C.
Oh, I'm sorry. It's angle B that we're relating. Okay. So angle C, I can't see that without my glasses. Then when I put on my glasses, I can't see the board. Okay. I mean, it's a catch-22. Okay. All right. So angle C is equal to 85 degrees. So let's let this be angle B up here, angle C or angle A down here. And side C opposite angle C is 6 units long. And side B opposite angle B is 5 units long. So the law of sines says the sine of angle B divided by the length opposite angle B is equal to the sine of angle C divided by the length opposite angle C. Okay. So B in this case is 5. Little b in this case is 5. Angle C is 85 degrees. And little c is 6. So now if we multiply both sides of this equation by 5, 5 on the left, 5 on the right, 5 cancels on the left. We have the sine of angle B is equal to, right, sine 85 degrees times 5, or 5 times the sine of 85 degrees over 6. And so that is the relationship between angle B and angle C, and sides B and side C, with the law of sines. Okay? And that's all you need to know. So Wednesday night, Thursday night, and then once I get approval, I'll send out an email about Friday night. But I'll send you an email out about Wednesday, Thursday, and Friday night. Okay? All right, have a great day.